We'll take the first problem. So this is the data set given. The weight in grams and length in centimeters of a particular fruit is given. If these are the values, then it is classified as the first type of fruit. And if this matches with these attribute values, then it is classified as the second type of fruit. So initially what these values are given, since we have two inputs, so this can be considered as your x1, x2. So we have only two inputs. So this is your target, or it is your label. So it is a classification problem. So initial weights for these inputs are given. W1 equals to -30, W2 equals to 300. Bias, a constant, is given minus 1230, and the learning weight 0.01. In sometimes this learning weight is also represented with this alpha value. So either this value or this notation. So what we are supposed to do is we need to train the model using Perceptron and classify the unknown instance with weight equals to 140 grams and length equals to 17.9 centimeters. It is nothing but when you give x value as x1 value as 140 grams, then length as 17.9 centimeters. So the model has to predict or classify whether it belongs to the C1 fruit or C2 fruit. So this is what we are into, but we'll be doing it by using what the perceptron. Fine. So you can see here x1 and x2. If I just represent that as a perceptron, so this is what we are going to get. So w1 and w2, x1 and x2, b equals to -1230. So we have a signum function. So if we are using the signum function, it is nothing but +1 and -1. So when +1 and -1, if it is greater than or equal to 0, if it is less than 0, then it is -1. So initially what we'll do is, since each time, fine, we are going to check whether the target value are nothing but this one minus the obtained value. The obtained value is what is that is obtained from the neuron, whether this minus this is 0. If they are getting 0, if t minus 0, if t minus 4 is what 0 value I'm getting, then there is no need to update the weights. Otherwise, there is an error, so we need to update the weights. So since I need to check this value with the obtained value from the neuron, I need some numerical values. What I'll do, whichever the fruits belongs to the first category C1, I'll represent them with +1. Whichever the fruits belongs to C2, I'll represent that with what, -1. Fine. So we'll see finally where what we get, whether +1 or -1. If the final answer I get is +1, then I'll classify that fruit to C1, otherwise to C2. So these are the initial values that are given. Fine. So we can assume or it is given already. Fine. So if I just plot these values here in a graph. Fine. So this is how the graph look like. So we are into identifying what I need to identify this boundary function. Why so? When I identify this boundary function, to this boundary function, I can give the input for which I need to classify whether it belongs to class C1 or class C2. Right? Now we'll start with the problem now. So initially what I'll do, so we'll consider the first instance. What is the first instance? We have 121 and 16.8. So this is x1, this is x2. So these are the initial values that are given. So what we are supposed to do, first we have x1, we have x2 from here. Then these are associated with the weights. We have bias. So we have W2 as well as W1. So we need to find the summation. What is the summation? That is W1 into X1 plus W2 into X2 plus the bias. So that is the formula I have written here. So W1 into X1 plus W2 into X2 plus the bias. Substitute the values. When you substitute the values, you get 180. Fine. So it is nothing but whatever the summation output I'm getting, it is 180. This I'm going to give it to which one now? Activation function. So what is the activation function I'm using? +1 and -1. If it is greater than or equal to 0, +1. If it is less than 0, then -1. So what is the output? 180 is given to the activation function. In 180 is given to the activation function, it will check whether this 180 is greater than or equal to 0. Yes, definitely it is greater than 0. If it is greater than 0, what is the output I'm going to get? It is +1. So hence classified as what? +1. Fine. Now check. So output what I am getting is that is 1. Now ends check. So this is my obtained output. What is the target output I have now? Target output is also +1 because I'm telling whichever the fruits have C1, I'll represent that with +1. Whichever the fruits we have C2, that I'll represent with -1. So target is 1. So ends, but what is the answer obtained? 1. 1 obtained answer is also 1. Fine. Then target answer is also 1. So when I do T minus obtained output, what I'm getting? I'm getting 0. It is nothing but we are getting this and this are same. Hence, it is classified as C1. Correctly, it is giving the output similar to that of what given training example. Hence, there is no need to update the weight because it is correctly classified. So this is what we are doing. So if this is the thing, what we'll do, we'll go with the next instance. So consider the next instance. When you consider the next instance, again we get W1 into X1 plus W2 into X2 plus B. So substitute the values. When you substitute the values, what I get? Minus 90. So when I get minus 90, so +1, if it is greater than or equal to 0. If it is thing, -1. So I'm getting -1. But in the output, what I'm having for the second instance, it is +1. But what I'm getting here, it is -1. The obtained output is -1, but the target output is 1. So the target output is what? 1. Obtained output is what? -1, which are not correct. So hence what we are going to do? Yes, which is not correct. So hence because both the values must be same. Hence here we are going to update the weights. Fine. Now how we are going to update the weights? The weight is updated by using the formula, that is initial value plus delta Wi, where this delta Wi is equal to what? That is, it is given with what? Nu into, that is T minus obtained output into Xi. So this is the formula we'll be using. Right? Or directly I'll be using something like Wi equals to Wi plus the learning rate, target output minus the obtained output into Xi. Obtained output is what I have obtained by doing the summation and giving this value to the activation function. Fine. I'm getting -1. Target is what? It is from what? It is from the data set. So with this, we are going to update the weights. So finally, we are updating the weights here. So how many weights we have? W1, W2, and even you are supposed to update the bias also. So whenever you are updating the weights, along with that, you are also updating what? The bias value. So W1 equals to, fine, W1 plus the learning rate, T minus obtained output into X1. So W1 is -30. Then learning rate is given as 0.01. Then target value, that is T, from the data set, it is 1. Obtained from where? From the neuron. That is the obtained output from the neuron. Obtained output is what? That is -1. Substitute the value into 114. So you will get. So this is the new weight. This is the new weight for W1. For W2, in a similar way, substitute the values 300 into 300 plus 0.01. Substitute the value into X2 value. X2 value is this one. X1 value is this one. X2 value is this one. Substitute it. We will get the new weight. Then the bias initial value is -1230 plus the learning rate minus the target value into target value minus the obtained value into x naught. X naught is always equal to what? That is 1. So these are the new updated weights. That is W1 with the new weight, W2 with the new weight, and bias with the new weight. Now, when you consider the next instance, you are supposed to consider this new weights, not the old weights. Now consider the third instance with the new weights. So these are your updated weights. Updated weight. So again, use the formula, summation formula, W1 into X1 plus W2 into X2 plus B. Fine. Then substitute the values. You will get less than 0. So from the training example, you can see the third instance is -1. Whenever you have less than 0, what is the output that what is the output from the activation function? It is -1. So it is correctly classifying. It is nothing but the target as well as the obtained output. So this is your obtained output. Okay, so obtained output, the target output from the data set. Even it is -1, the obtained is also -1. So hence correctly classified. So no need to update the weights. Fine. Next, consider the fourth instance. When you consider the fourth instance, so this is your x1, this is your x2. These are the weights you need to consider. Do the summation. You will get this one. This is given as an input to your activation function. Since it is less than 0, it is classified as -1. So the target is also -1. Obtained is also -1. Hence, it is correctly classified. So this completes with one cycle that is called as epoch 1. Fine. Now, what we do is we have to start the next epoch. Why we have to start the next epoch? Because whatever the weights that are updated, this we have not checked with what? We are not checked with the first instance, because the first instance was calculated with the help of the initial weights. So again, we have to start with the next epoch or the next iteration and check whether these updated weights, they really works well with all the inputs or all the instances given in the training examples or training data set. So take the updated weights and check whether it classifies the first and the second instance correctly, because already we have done with the third and the fourth instance. So we'll try to short down the calculations here. So first instance, initial weight is 121 and 16.8. So these are the updated weights. Substitute the values. So this is x1, x2, w1 and w2 bias value is there, because the first instance is classified as +1. The next third and fourth is for -1 and -1. So it is greater than 0. So when you give this to which one? To the activation function, what it is going to output? It is going to output +1 classified correctly to the class C1. So even it is doing well, doing fine with what? The updated bits. Consider the second instance, even substitute the values. So this will be x1, this will be x2. So this is given as an input to the activation function. Since it is greater than 0, this will be as what? +1. So it is correctly classified. So the third instance and fourth instance is already correctly classified with the updated weights. So this completes with the epoch 2, and we'll stop the process, because even after the second iteration, these weights are not changed. Once the weights are not changed during the epochs, then stop the process. And finally, what we'll do, we'll get the classification boundary. Why? Because now x and x2 initially, whatever that is present in the data set, training data set, we have taken that and we have come up with the function. So weight w1 is what? The new weight, this one and this one, and the bias value. So we are substituting in the equation, that is w1 into x1 plus w2 into x2 plus the bias value equals to 0. Now these two are adjusted. These weights are learned now, right? So that when new instance is given, that is new x1 and x2 value are given, we'll give this as an input to this boundary function, and we'll see whether it gives the value that is +1 or -1. Fine. So consider the new instance. Why we are considering this new instance? It is given in the question that when a new instance is given with weight 140 grams and length 17.9 centimeters, I need to predict whether it belongs to C1 or C2. Correct? So what we'll do is take this, take the new values 140. So this is your x1 value, x2 value. Substitute this in this boundary equation, that is your equation here. So it is -27.72 into x1 plus 300.304 into x2 minus this. So it is 265.56. When you give this as an input to the activation function, since this is greater than 0, the activation function outputs what? That is +1. Hence, this one, that is a fruit with the value that is 140 grams and 17.9 centimeter. It belongs to which class of fruit? That is C1 category or C1 class of fruit. So this is how the classification is done with the help of the perceptron or the neural net.